Given the acceleration vector, the initial velocity, y naught, v naught, and the initial position, defined by the vector with components x naught, y naught, find the velocity and position vectors for t greater than or equal to 0. So let's begin quickly here by recalling that we can define a velocity vector, v of t, by integrating the acceleration vector with respect to our arbitrary parameter t. So that's where we're going to begin. Find the velocity vector. So here we go. We can say that our velocity vector, v of t, is defined by the integral of the vector with components 0, 12 with respect to t. So integrating, the antiderivative of 0 is 0, of course, and the antiderivative of 12 leaves us with 12t plus an arbitrary constant vector c. So we can say that, therefore, our general solution for this velocity vector is defined as the vector v of t being equal to the vector with components 0, 12t plus this arbitrary constant vector c. Now, we don't just want the general solution, we want a particular solution. So let's keep in mind here that we are given an initial condition. So IC for initial condition is our initial velocity, the vector with components u naught, v naught, being equal to 0, 6. So another way to think about this initial condition is that at the very first t value, where t is equal to 0, the velocity at t is equal to 0 is defined by the vector 0, 6. So we're going to take our general solution here and evaluate at this initial condition. So here we go. We have the vector 0, 12 times 0, plus our arbitrary constant vector c is equal to the vector with components 0, 6. Now, of course, we know that 12 times 0 leaves us with 0. So solving, we can see here that this arbitrary constant vector c is 0, 6. Beautiful. So we can take this constant vector and plug it back into our general solution and make the final conclusion, the particular solution for our velocity vector is vector v of t, and this is equal to the antiderivative 0, 12t plus the vector, the scalar valued vector 0, 6. And we want to simplify. We want to combine the like terms here. So combining these up, our beautiful final answer for this velocity vector, 0 plus 0 is 0, 12t plus 6, simply 12t plus 6. So there you have it. This is the velocity vector. So now that we have this beautiful velocity vector, we're going to take this velocity vector and use it to find the initial position. And we know this because we can recall that the position vector, vector r of t, is defined as the antiderivative of the velocity vector, integrating with respect to t. So here we go. Let's find our position vector. So giving ourselves plenty of room, we are ready to find the position. So we have vector r of t is defined as the antiderivative of the vector with components 0, 12t plus 6, integrating with respect to t, and this leaves us with a position vector. So integrating 0, we're left with 0 again. Integrating 12t, we are left here with 6t squared plus 6t, and plus this arbitrary constant vector c. So this is our general solution for the position. But again, we want the particular solution. And let's keep in mind here, what was the initial condition that we were given? We have the vector x naught, y naught, which is defined as 4, -1, And again, an equivalent way to think about this is that this is the position vector evaluated at that first t value. T is equal to 0. So we are going to replace every t that we see in the general solution above with 0 and solve for our arbitrary constant vector. So solving for c here, we have 0. And then we have 6 times 0 squared plus 6 times 0 plus that arbitrary constant vector. And we're setting this equal to the vector with components 4, -1. And look at this. We have the 0 vector again. We know that 6 times 0 squared is 0, 6 times 0 is 0, and we can pretty quickly see that our arbitrary constant vector is the vector with components 4, -1. So therefore, our beautiful final answer for the position vector is vector r of t, and this is equal to our general antiderivative, which we found to be 0, 6t squared plus 6t, plus the initial condition 4, -1. And of course, we want to simplify this, combining up our like terms. We are left with the position vector, vector r of t, and we have 0 plus 4 is 4. And then we have 6t squared plus 6t minus 1. And so there you have it. This is our beautiful final answer.